the introduction, and thank you for this poll that really shows us that we have a mix of experiences with us today. Really welcome to everybody. It's going to be very interesting to be able to communicate and share with you my experiences in this webinar today, which I hope you will benefit from. Just let me remind you that really the focus of the webinar today is on assessment. So if you are new to the IB, really the focus is just on assessment. So hopefully you'll become more familiar with the IB assessment philosophy. Obviously, those of you who are not new to IB, you might be already familiar with that, but it's a good reminder for us to put the internal and external assessment in chemistry in context. We'll look into the internal assessment components, like what are the lab skills that you really need to have developed with students, what is an IA, how can we actually apply the IA criteria, and we're going to practice with that, marking some students' work. We'll also look into the external exam papers. We'll practice with some database question and experimental question, and this is just to put you, again, to increase your familiarity with the different methods of assessment in IB, which we're going to go over very soon. Then we'll end with how is it that we can do, as teachers, how can we integrate internal and external assessment skills into our course throughout the 2 years. So we'll share some ideas there. And then we'll end up with what is it that we need to report to the IB and how do we actually do that. So please, again, remember that our focus is on assessment, not curriculum, not syllabus, just the assessment. So to put the internal and external assessment in context for chemistry, we need to look into what IB sees as the assessment philosophy. What is the assessment philosophy in IB? They do see that actually assessment should be part of the teaching and learning. It should support the learning, support the curriculum achievement and standards of what the course is all about. There are both the external and internal assessments in chemistry, but of course, throughout the DP program, whether chemistry or not, there is always an external and internal component to the assessment. Normally, the IB examiners mark the work produced for external assessment, while the work that is produced for internal assessment is normally marked by teachers and externally assessed by IB moderators. Now, these 2 recent years, things have been changed a bit, but this is due to COVID and things like that, but we'll talk about that later on when we really focus on the internal assessment. So the types of assessments actually that IB promotes is definitely what the research has really been talking about throughout these recent years. They do encourage formative assessment, of course, because this is important for informing students and teachers about the progress of the learner. Where is the student at a certain particular time? What strengths do they have? What weaknesses do they have and need to work on so that they can achieve the aims and the objectives of the course? And there is obviously the summative assessment, whereby after all the learning has occurred, what is the student able to do? So we measure the student achievement. So clearly, we know that the IB really, the assessment or the grade in IB is focused on the end of the 2 years program. It's a summative assessment, and that's what the student actually will be able to give, or the IB will actually assess students based on this last summative assessment. However, IB does encourage throughout the 2 course, throughout the learning process, that students really use formative and summative assessment throughout the 2 years to enrich the learning, promote the learning, and facilitate the learning. Of course, there is no comparison to be done between students. So in the IB, the belief is that actually each student is separate from the other, different from the other. So the achievement is based on criteria, specific criteria set by the IB. So it's criterion, all assessments are criterion related, not norm referenced. We do not compare students to each other. We actually judge students' work according to the performance, according to certain levels of attainment. Of course, once you enter, for those of you who are new, the IB does offer a lot of resources to support the teachers in their teaching of the program. So you should not really worry too much. I'm sure those of you who have started the program know that this is available, and a lot of guidance is given by the IB. So there are several methods by which we actually assess the students' work. We have assessment criteria, like for example, for the IA in chemistry, we actually assess student work based on given set of criteria. And normally the task is open-ended. And there are skills that students need to demonstrate to achieve these criteria, to demonstrate that they could actually meet those criteria. We're going to look into, this is normally in chemistry, this is basically done with the internal assessment. So for example, these are the criteria that we use for the internal assessment in chemistry: personal engagement, exploration, analysis, evaluation, communication. And we're going to actually look into every single one of them throughout the session today. So there are certain marks associated to every criterion. And basically, you just come up with a total grade based on what the student has achieved on each of these criteria. Now, within the criteria, and again, we're focusing on the internal assessment at this stage, there are some descriptors. And descriptors could be different from each other. They're graded independently of each other. And we normally, for example, to give you an idea, for the descriptor of data analysis, when you look at the highest achieving grade, you can see that there are four descriptors in this assessment criterion. And normally we use the best fit model to assess students. And again, we'll come back to that throughout the session. As you saw, there are mark bands for every for every criterion, there are mark bands. And so the mark bands, again, we use the best fit approach model. Some teachers struggle with that notion if they're not been familiar with mark bands. But for example, you can see that for these, if the student achieves the criterion within these descriptors, then he would achieve a 1 or a 2. So many teachers struggle with, okay, so is it a 1? Is it a 2? Again, we use the best fit model approach to actually determine which is the most appropriate grade, and we'll come back to that throughout the session. There are also other methods of assessment in the IB. We have analytical mark schemes, and that's normally done with the external assessment. So this is normally on the exam. There are mark schemes given for the answers, and students should really be able to answer questions based on the syllabus coverage, of course, but also on the specificities that IB requires for them to achieve certain marks. Normally, for every exam session, the examiners are sent these mark schemes. We all follow them. And sometimes there are marking notes to accompany these mark schemes to, again, clarify what is it to, how is it that we can associate an answer to a certain particular grade. So we're going to look into, so this is a general overview of the IB philosophy, and this really gives us the background for looking into the chemistry assessment. And it is put in context based on this philosophy and the methods that IB uses. So like we said, and like we reviewed before, there are both external and internal assessments used in the chemistry course. And normally, again, it's the exams are taken by the students at the end of the 2 years, and it's only external IB examiners that actually mark the work. While normally, the internal assessment is marked by teachers, but moderated by the IB moderators. Now, obviously, due to COVID restrictions, these couple of years, it was not really moderated. It was regraded all by the IB, but again, we'll talk about that in a while. Students have to, the assessment objectives in IB chemistry are really typical of the chemistry course. Students should demonstrate knowledge of certain facts, methods, scientific information. They should be able to apply those. They should be able to formulate, analyze, and evaluate hypotheses, methodologies, data, explanations, and they should also be able to demonstrate certain skills related to practical activity. Now, as you can see, the external assessment actually targets objectives 1, 2, and 3, while the internal assessment really clearly targets objective 4, but also, if you think about it a little bit, also objective 3. So again, this puts in context both in the external and internal assessment in terms of what the students should be able to do. We're going to start with a focus on the internal assessment, and then we'll move into external assessment a bit later. Now, we often, when we talk about the internal assessment program in chemistry, people just think about that one individual investigation the students have to do and that we send to the IB for moderation, etc. While really, it's more than that. It's really a whole entire program of practical work, laboratory skills that we want to develop in the students. So normally this is done throughout the 2 years. And students, whether you're standard level or higher level, the students are all graded in the same way, assessed in the same way, required to do the same type of work, and required to develop the same types of skills. And again, ideally, these skills should be developed throughout the 2 years. It's a science course after all. It's not just about meeting a certain IB exam deadline. It's also about students developing skills in this this program. And so again, we often confuse the internal assessment with the individual investigation, and the individual investigation is part of the internal assessment program, and it should be really like an outcome of all the skills that students have developed throughout the program. So again, it's IB requires that students actually get involved in an IA program that lasts for 60 hours for higher level, 40 hours for standard level. This includes the 10 hours for the individual investigation that will be moderated and assessed by IB. The rest of the hours is really for students to develop all those skills that will be required to make them really do a very good individual investigation. Throughout the program, students are required to use some IT skills. The IB actually outlines those skills in the documents that they normally develop. And again, it's the same requirements for both standard level and higher level. The only difference is the number of hours that are being covered. Again, the way you want to program this or develop this program, the internal assessment program, really depends on you, on the resources of the school. They could be mostly hands-on experiments. You could actually, or you are actually asked to expose students to some type of spreadsheets where they can actually take data and work with them. Databases, same thing. Simulations, if you can expose students to some, there are many meaningful simulations, and IB does share some links to those. Often during the quarantine or lockdowns, students had access to a lot of those simulations to do some experimental work, because of course students were not able to go to school, and that was really useful. There are really good ones out there, and more of them actually. Now, there are some skills that are required. So while IB does not tell you you need to perform these particular labs or you need to do this particular lab, they do require some skills to be really highlighted or developed within the course. And you will wonder, you will say, okay, so how would they know that actually we've covered them? Well, assessments, the exam at the end of the 2 years does have a component for experimental questions. And we're gonna see that when we talk about external exams or the external assessment. And there are many questions related to these mandatory skills. Like, for example, students need to be able to perform or analyze data related to experimental work on determining empirical formulas using nuances. Students need to be exposed to titrations, to indicators, to pH meters, to universal indicators. They need to have done some kind of investigations on rates of reactions, calorimetry, molar mass of gas in the lab. And so again, you can see that there are some required skills that students, or some required lab skills that students really need to develop throughout the 2 years course. And again, it's something very important to understand that this is really important, because many questions on the exam come related to these, and students should be able to analyze and evaluate data related to such mandatory skills. So we call them skills. You could call them labs, but really they're skills if you think about them. So the individual investigation, the one that actually people just focus a lot on, because of course it's moderated and it's graded by the IB, so it's understandable. Yet it's not the only part of the internal assessment program. It should take about 10 hours of class time. And really, it's the individual investigation of the students. They pursue something that is of interest to them, and they design it, they plan it, they perform the whole experiment, they collect data, they evaluate it all on their own, of course, with your facilitation and guidance, of course, but it's their investigation. They just do it, they plan it, they design it, and they do it from A to Z without any input from you except for guidance or feedback, or if they ask you questions, of course, and you are entitled to answer them. And this normally counts 20% of the IB score that they get, the official IB score. Like we said, it targets objective 4, and it should not be seen as a small version of the extended essay, rather just really an exploration. And of course, there is a totally different focus on, when we compare IAs and extended essays. They have totally different intentions or purposes, really, if you think about it. But again, that's not the scope of this webinar, but IB also does provide guidance related to that. It's truly crucial that you are able to testify for the authenticity of the work, that the students have performed the lab, that they have analyzed the data, that they have, so it's their work really, and it's not someone else doing the work for them, because you will be asked to sign something related to that. So normally, again, like we said, you will internally assess the IA, you will predict the score related to the criteria, and you will report this to the IAB. But again, we're going to talk about what is required of you at the end of the webinar. And the IB examiners grade it externally to moderate the sample that you would be actually showing that. So normally it's very important to explain your grades to the moderator. So you normally would annotate your work. Anyway, you are required to fill in a form where you justify the criteria grades. And honestly, this is truly important because IB does want to support teachers in how they grade the IAs. So when there is agreement, I'm an IA moderator, and we are always encouraged to support teachers with the grades, unless really it's truly wrong or completely wrong, and that is where we change the grade completely. However, if like for example, I predicted 3, the teacher had predicted 4, often if there is valid evidence given by the teacher through those comments, we support the teacher with that grade. So it's important that you provide evidence for why is it that you're given a particular score to the student. There are no word limits for the individual investigation, which is really a blessing in a way. So the students are required to limit themselves to 12, 13 pages is all right, but that's really the maximum with bibliography and works cited. This is really because we want to teach students to communicate in a concise way. And this is really a very appropriate length. I've seen it with my students. It's truly an appropriate length. They are able to communicate their work very clearly within that limit. There are no particular formats to follow or templates to follow, as long as the criteria are all met and addressed within the work. So I want to remind you that these are the IA criteria. There's personal engagement, there's exploration, analysis, evaluation, and communication. And we're gonna actually go over each one individually. And that's why I'm gonna skip this slide, which summarizes each one of them, because we're gonna go in depth into actually each, and for the sake of time, I'm doing this. So we're gonna go through some guidance for the IA. I'm gonna first tell you a little bit more about the descriptors. Apologies for those who have a lot of experience with that, but I think I need to address the needs of the teachers who are new to the program as well. The descriptors is the first step we're gonna go through, and then I'm gonna show you a sample IA, and you're gonna be asked to actually associate the work with some grades that we're gonna see here. So the first criterion is related to personal engagement, and this normally encompasses the whole entire report and the work of the student. It's not a particular part of the report. It's more something that the student will show throughout the whole report. So is there really evidence that the student has done this independently? Was the student creative in the approach and changing a method and taking initiative into making those changes with justification? Does it really clearly show that the student was interested and it was really, there is a personal significance to actually tackling this IA? So basically, this is really what we want to see throughout the report, the person engagement. Most of the time, this is mostly a teacher thing because really it's the teacher who has worked with the student. But again, if the report itself does not have evidence of this, the moderator could mark it down. The second component is exploration. So normally this is where the student starts designing the lab. And so is there a very clear and focused research question stated in the beginning of the report? Did the student investigate the background information that is related to that research question? Did the student come up with a method that is clear, that is actually taking into consideration all significant factors that can affect the data? Is there room for the collection of sufficient, pertinent, reliable data? Is the student aware of all safety, ethical, environmental issues related to the lab work? So this is really the exploration component. The analysis is related to the data. What did the student do with the data? So is there sufficient data in the report? And normally, of course, this data should be quantitative, qualitative. Is it meaningful? Is it relative? Is it really clearly stated with uncertainties, with units, etc.? Did the student process the data well, accurately, with no mistakes? Is it actually allowing the student to reach to a conclusion that will help answer the research question? Did the student measure the effect or the impact of uncertainty on the data and the conclusion and the concluding results? And will there be a good interpretation and conclusion related to all this data processing? Finally, there's the evaluation, or not finally, but finally in terms of the write-up, there is the evaluation component that where the student has a detailed conclusion, a conclusion that is actually compared to some good accepted scientific context. Did the student discuss the strength and the weaknesses of the investigation? Very well, and not superficially, that's really important. And did the student suggest some realistic improvements and a possible extension to the investigation? So this is really the second, third, and fourth criteria. They're really more related to the write-up, the report. While the first one, person engagement, while it should really transpire throughout the writing, it's more of a holistic type of evaluation. Same thing for communication. This is more related to the entire report rather than just a particular aspect of the report. So the students, we just look after we've read the whole report. Okay, is the investigation clearly outlined? Is it clear what the purpose was and the conclusion is related to that? Is there coherence? Did the student really put good tables and good data headings and for the tables? Did the student obey all the conventions of chemistry? Are the formulas written well? So this is really the communication aspect and how concise the report is. I mean, if there's too much irrelevant information, or now was the student able to really be concise and limit himself or herself to the 12 pages? So this is normally the overall type of evaluation that we get towards the end. So this is in brief what the IA criteria is all about. So what we're going to be doing next is we're going to actually apply these criteria. And I'm going to ask you to look into one IA that we have actually. There is a link in the chat to a Padlet that takes you to a lot of resources that I'm going to be using throughout this webinar. So there is an IA that I've put, the first one, resource number 1. If you can get through it, I'm going to give you about 5 minutes, hopefully, if we can achieve that, for you to actually skim through it. Skimming meaning don't read in details. I'm sorry, but we don't have much time for that. But what you can do is skim through the report, and then I'm gonna project each criterion at a time, and you're gonna try to give a mark, and then I'm gonna give you the real mark and tell you why is it that it has been graded this way. So from now, if you can go to the Padlet and check the first resource number 1, IA, grading an IA. And if you can actually get 5 minutes, and we'll come back to this session. So take 5 minutes, please, to go through that IA. 5 minutes have passed, but I understand that you would want even an hour sometimes to explore an IA, and I understand they take some time to really read carefully and thoroughly. What we're going to be doing, we're going to try our best. It's just an exercise for you to get more familiar with the criteria rather than really exploring an IA and giving it to a very accurate result. So we're going to first attempt to look into the first criterion, which is personal engagement. From your first review of the paper, and it's okay if it's not accurate, don't worry about it. We don't have names, it's anonymous. What do you think your score would be? And again, when you see that you have sometimes more than actually like sometimes the descriptor, you have more descriptors taken from this, then you would definitely put a 1. If there are more descriptors in the 2, then perhaps you want to be lenient and give it a 2. So I see from the poll that actually most of you chose the 2. And the grade is 2. Well done, everybody. So while I was not judging for the accuracy of the answer, but that's good. You felt that the student really had demonstrated quite a lot of engagement with the investigation, that they've really tried to put some initiative, creativity, etc., which is great. So we're going to look into the second criterion now, the exploration component. Is there a relevant and focused research question? Is the background information provided entirely appropriate? Is the method, etc.? So try to put some score for that criterion as well. Again, it's just getting used to and being familiar with the assessment criteria. Okay, very good. So again, for the sake of time, I'm gonna just move ahead with that. There is, as you see, there is disagreement between the 5 and 6 and 3 and 4. And in all honesty, this is really common. And when you're new to the IA and the IA criteria, you will tend to be generous sometimes, or sometimes you will tend to be less generous. And that is a very normal process at the beginning. And that's why sometimes working with colleagues on the papers helps actually learn how to best evaluate these papers. And while the grade really is a 4, and I'm going to explain to you why that is actually in a while. Okay, so I'm going to go over each criterion, and then we'll understand why is it that it could actually be a 4. Analysis, in terms of the data, is there enough data? Is it processed well? Is the student reaching to a valid conclusion? Is the student interpreting the data very well? What do you think about the data analysis? Where is your choice in there? So, good. Okay. So again, there is disagreement. You can see that a lot of you have chosen the mark band 5, 6. Some of you 3, 4. Very interesting. And the grade is actually a 4. And we'll talk about that again. I'll show you why in a second. We're gonna go to the last one, which is evaluation. Is there a valid conclusion? Is the conclusion related to an accepted scientific context? What are did the student evaluate strengths and weaknesses? Is the student aware of the methodology? Is the student providing realistic suggestions for improvement? Wow, almost equal in terms of the mark bands, 3, 4, 5, 6, equal percentages. And it's sometimes tough, by the way. You are always sometimes worried whether you're too generous or not too generous, and knowing the students makes it even harder because you know the skills of the students sometimes even. And the grade was a 5. And so some of you might have chosen 4, 5. Really, what is the distinction? It's sometimes very hard to really decide. And the final one, communication. What do you think did the student communicate clearly, properly? Was it well structured? Was it relevant? Was it concise? Did the student make any mistakes with terminology, conventions? And I see here that the majority of you has chosen a 3 and 4 mark band, and the student got a 2. And we're gonna actually, what I'm gonna ask you to do, because of course many of you might have question marks at this stage, please go to the Padlet again. There is the second resource gives you actually the comments In red, there are the comments related to the criterion itself, while the green gives more justification. So if you can go to that document, I will give you about 5 minutes again to go and skim through the comments to justify the criteria. But again, we'll talk about in a second about actually that aspect of how do you really know and how do you determine that, etc. So 5 minutes or maybe 4 if we can, for you to skim through the comments, and we'll be back in 5 minutes. Okay, everyone, I think you can proceed with looking at it while I'm just mentioning a few points. I'm not sure if everyone was able to identify that really the main problems with this paper, while very thorough, honestly, and very sophisticated in a way as well, the student has provided suddenly two research questions, if you think about it, while this reduces the, how concise the report is. Because when you start putting too many, you need to have a very focused research question. So when you start creating subparts to it, it loses the whole focus of the paper. So that's one major disadvantage or weakness in the paper. The other weakness is really the fact that the student has started analyzing, processing data without having had any introduction of that in the background. Suddenly he's using formulas and equations that are not justified by the theory. He should have provided more solid background to that type of analysis that is not common in chemistry. And so he should have really explained the rationale behind that type of processing of the data. And if you think about it also, there are inaccuracies in how he's processing the data, and why is the width only actually going to change? Why not the length? And why not the width as well? So there are actually many aspects that could actually create problems with actually, I'm sorry, I went ahead. It's okay. So I want to open the floor to one or two questions that you might want to ask about the practice paper we've had. We don't really have the luxury of time. At the end of the session of the webinar, I'm going to ask you to stay if you really want to ask more questions. But we are able, Sarah, I think we can take one or two questions. Sarah, are you going to be able to read the question if there is any, or should I look into the chat? How?
No,
Okay,
I would be following up on the chat.
Okay,
if there are any questions.
If there are any very, urgent and burning questions related to that IA that you've practiced with. Otherwise, you can go to the Padlet. So while we're looking and listening to the questions, you can go to the Padlet and look at the top scoring IA. Again, these are from my students. And you can look into what it means or what should be a good paper. That student scored a 23 out of 24 and it was accepted by moderators. And it's really a very well done paper. So you can go ahead and access that if you want while we take in questions that Sarah will kindly read. Thank you.
Up to this point, no one has posted anything in the chat box, but the minute they do, I will share that with you.
Okay, very good. Yeah. So I'll give you a few minutes to skim through that top scoring IA for you to get a better feeling of how focused a paper should be, how, like everything should be all coherent from the research question to the evaluation. The whole paper has to be coherent. So the student has to follow. That's why I always tell my students, have a very focused, well-stated research question, and then you have your IA done. Honestly, this is really the start. That's why I work a lot with my students on identifying a very, very clear and focused research question. Because once they have that, then everything follows. All the parts will follow very smoothly. And of course, it's hard work, but still, it will be smoother for them to work on all the other parts. So a few minutes for you to look through that paper.
Ms. Dania, we have one question
Yes.
that states, what kind of data analysis is generally expected in chemistry internal assessments? Is, for example, ANOVA test allowed in chemistry?
No, in all honesty, we don't want to complicate things for students. And it's very important that normally the students just proceed with chemistry. It's not like biology where they might have a lot of tests over so many different days, so many different trials. Normally we really restricted to 5 data points, 3 trials for each one of those data points. And so normally students should be able to process this data very quickly, very concisely with an Excel sheet, and that really is more than enough. What is important also to understand is that in chemistry, students are not required to draw error bars on graphs, for example. They just have to be able to propagate error and come up with a % error for the lab that is related to instrumentation, and compare that and evaluate that versus the % error that they could generate. So really the best IAs, honestly, and that's from experience, the best IAs are the IAs where the student has chosen 2 variables, quantitative variables. They try to study the relationship between these two, graph the data at the end, and conclude. And normally the equation is given to them. So there will be an equation for the line, the best fit line, and the R value for the graph. And really, basically, this is more than enough. That's it. So the less complicated it is, the more successful they can be. So once they start with those complications, they can just get lost. When they have so many other pressures and so many other IAs, so many other deadlines, they'll become very pressured with time, and so they will get lost. Really make it very clear, very focused, very just straight to the point. They can just go straight into, just calculating whatever they have to calculate, averaging the data, plotting the data, coming up with a conclusion, and that's just doing a % error calculation and the % uncertainty calculation. Really, it's neat. It's straightforward, and it gets them really very good marks. If they really are addressing all the criteria, that's it. That's what we want. So don't always, there's some people think that or students or even teachers sometimes think that, the more sophisticated and complicated I can get to do the IA, the more scores I will gain. Often it's the opposite. Often it's actually they get lost and they don't know how to do it. They're not at the college level yet. I've learned a lot of the things they're learning in college, even at my last years of college. So it's okay. As long as it's focused, straightforward, they don't need to have it very complicated, very sophisticated, really. That's my advice to all of you. So I think, anyway, at the end of the webinar, you can stay, and anyway, you can also review the Padlet information more, and you can ask me more questions. Let's proceed with trying to look a little bit at the external assessment in chemistry. And we'll end with some advice on how to do things and etc. So the chemistry external assessment really is an exam, okay? So it's an exam made up of 3 papers, paper 1, paper 2, paper 3, and we're gonna talk about the focus of each paper. They all focus on the first three assessment objectives we reviewed before, and it follows the method of analytical mark schemes with some notes related to those. There are answers provided by IB examiners that we need to actually use to evaluate the papers. And it counts, remember, 20% was the internal assessment, 80% is the external assessment. So very quickly, paper 1 is just multiple choice questions where students cannot use calculators, they just have a periodic table, and the questions are made in a way that students don't really need a calculator. Again, it assesses all 3 first objectives we've seen before. It's 45 minutes long for standard level. It's higher level. It's 1 hour again, because there's more material for higher level. So it covers really the core syllabus of the course with the additional higher level material for higher level. Paper 2 is more of answers that they need to provide to certain questions. There are no options. Students need to answer all the questions. And again, they target objectives 1, 2, 3. They are on the core syllabus, the additional higher level material for higher level. That's why it's much longer for higher level. 75 minutes for standard level, 135 minutes higher level. Calculators now are permitted. Students have more than a periodic table. They actually have a whole data booklet of information that is made available to you. And my suggestion would be that students use it when they're doing homework, when you're practicing things in class, when they actually during tests, you give them a data booklet, let them get used to the data booklet and what it contains so that they don't spend hours memorizing information that they don't need to memorize. They know what is made available to them. Anyway, students, even when we tell them don't memorize the information, we use it so much that sometimes it just sticks in their brains, which is great. I mean, that's fine, but it's the reassurance that students can access the data booklet during the exam. Paper 3 now is actually made up of 2 sections. Again, they're all answers that students have to provide to questions. But section A relates to a database question and some questions on those, remember, the mandatory lab skills or practical skills that we have talked about before. So there is a one database question, one experimental question that consists of several subparts, basically. In section B, they need to answer questions related to the option, the additional option that you cover within the syllabus. And normally, the section A is the same for standard level, high level, exactly the same, nothing different, because remember, anyway, the skills were the same for both levels. While section B, the only difference will be the additional high level material in the option. That's why you have the 1 hour in common to both of them, same material, but 15 more minutes for the additional high level part of the option. Normally, paper 1 and paper 2 are done on one day, then paper 3 is done on the second day. I would recommend that when you practice with students or when you assign your own test, that you use a rule of thumb that for every mark associated to a certain answer, you provide a time of 1.5 minutes. Now, while this is plus or minus, it can vary, but in most exams, I've done my research, I've applied it to many exam papers, whether multiple choice, paper 1, 2, or 3, and roughly that's basically the count. So when you assign a test or when you assign a practice question in class, this is the time that you would have to give to the students, okay? This is really useful because often we wonder how much time should we provide? Are we being fair? Well, this actually gives you the answer. So again, for you to get used to the exemplars, if you, like we've done with the IA, really the idea was for you to get to see the criteria better and try to understand what it is that is required for providing a good IA, what is a solid IA. And really remember, it's not to be a perfect answer rather than to target specific criteria. Same thing here. For the external exam, you have to target the specific parts of the mark scheme that the examiner wants you to target. So what we're going to do is we're going to practice with a database question, then with an experimental question. And so basically, again, in the chat or in the Padlet, sorry, you have a link to a database question. Actually, it's an answer from a student. And the questions are there and the answer of the student is given to you. I'm going to show you on the screen here the mark scheme. And I would like you please to associate or to score the student paper with that mark scheme in question. Here, I would really welcome you to work in breakout rooms, discuss things with your colleagues. I think that would make it a bit more interesting in that sense. I've been talking. It would be nice for you to also share thoughts with colleagues that work like you with chemistry. So I'm going to project the mark scheme. Sarah is going to put you in breakout rooms and we'll come back in exactly 4 minutes. I don't think you would need more than that, or let's say 5 minutes. 5 minutes and we'll be back. All right?
Two breakout rooms, Dania, 5 in each.
Okay, very good. Excellent.
Okay, all right, we'll do that.
Thank you, Sarah.
Kripa, can we bring back the participants, please?
Sure.
Okay, Sarah, are we back from the breakout rooms or not yet?
Yes, I think we're back.
Okay, very good. Sorry, I don't know why I left the meeting. So everyone, you can look at the mark scheme of the database question. And you can see this is normally what would be given to all IB examiners. This is what they would actually give the examiners to grade the papers. And this is a typical, for those of you who are experienced, I'm sure you have seen such mark schemes. For those of you who are new, this is basically what you would get when your IB coordinator purchases the questions, and you can train students with those questions. These would be the answers. So you can see that every answer would be having a certain total of marks. And the way you actually look at it, they give you many possible suggestions. So for example, for the first question, they could either talk about relative values compared with the standard or not absolute measure. Any of these answers would guarantee 1 mark achievement. Same thing for the second question. So whenever you see a tick, that means that's a mark. When you see the word or, these are alternatives for the answer. This is a mark because you see here there is a two mark answer. So every tick is worth a mark. So this would be one part of the question that should be given, and this would be either or one of these answers, and so on and so forth. So I think we're going to change the way we're going to approach this in the second part. So this is a database question. So you can see that a lot of the answers can be provided by the student without them knowing much chemistry, but some of them will be related to the chemistry knowledge that they have developed in the course. This is, again, a typical database question, and you would need to actually make students practice with those. Are there any particular questions related to this database question? Or maybe we'll come back to the questions after the experimental question as well. But I think I would change the way we're going to actually do the experimental question practice. I'm not going to ask you to go into breakout rooms. I'm going to ask you to try to provide an answer to the questions, to the experimental question that is in the Padlet. So if you can find the experimental question practice, so here you'd have to answer it. The whole point of this exercise is for you to get familiar with what is an experimental question and how it is linked to the mandatory skills that you have actually been exposed to before. And normally here, I will ask you to then compare your answers to the mark scheme that I will show you. If you just can access that paper, and I think We will not go through the entire practice of you answering and looking. So again, if you can just access the paper, have a look at it, just for the sake of time, we're not gonna spend time answering it. I will show you the mark scheme. And this will give you an idea about what could be asked on an exam related to the mandatory labs. So these are answers, possible answers for the questions. I'm gonna give you about 3 minutes to skim through, no breakout room, no, you don't need to answer them. Just skim through the questions, look at the answers, and then I'm gonna open the floor for some questions if you have any related to both the database question and the experimental question. So take about a couple of minutes for this practice. So I hope you got an idea of how, again, students could be assessed on actually lab skills. And that's why it's really imperative that throughout the 2 years, students develop those skills throughout. I mean, many teachers tend to skip because of the sake of time and wanting to finish the curriculum. They skip a lot of the labs that they would normally be doing with the students, while I think this really would be at a loss for the students, because once they reach to the exams or when they reach to the IA, they're really lacking in skills. So it's really crucial that students are exposed to a lot of experiments. So I'm going to take 1 or 2 questions related to the experimental and database questions, and then we'll move into how do we apply all this in our teaching. And that I think will be the most important aspect. So 1 or 2 questions, very urgent ones, and then I can stay at the end with anyone who has more questions. Okay, so anyway, if you come up with more questions, I'm happy to stay at the end of the webinar just so we really honor the time. How do we put all of this together? How do we implement all of this in our course? Because I think this is mostly what people would, new to the IB teaching, would struggle with. So in terms of the external assessment, remember, IB has those 2 summative requirements at the end, the IA and the external exam. But they do encourage us to actually embed all these assessment techniques and methods within the course and within the teaching so that we actually facilitate the learning of the students. And so, for example, you are would be highly encouraged, not IB, I do that, it's my recommendation for you, is to actually use a lot of the IB questions in your lessons. So while you want to model how to apply certain skills, use particular IB questions from certain sessions. Normally, the IB coordinator would give you access to a data bank of questions for chemistry, all from all past exams. Use these to practice with the students, model how to answer a question, how to learn how to be more specific about, you know, when I grade and evaluate exams for the students, I can see that the student has taken a chemistry course, the student knows a lot of the chemistry, but they need to hit particular keywords for them to gain the mark. So it's also training them to think in that sense and how to actually answer specifically. Use some questions as formative working class, formative quizzes, formative questions that you might ask them. Of course, assign homework as much. I mean, I always tell students, the more you practice with IB questions, the better you'll be prepared for the IB exam. So give them as many questions to practice with as homework. Give them the mark schemes associated with those answers so that they can check themselves and how they're actually faring in terms of answering those questions. The more they practice with those, the more comfortable they'll go to the exam. And of course, use IB questions and tests. And this will also make sure that we're preparing students to think and to get an idea of how they will actually score on the IB exams. But again, try to remind students that this is all a learning process. So while for a certain topic they might not score very high, eventually their learning is growing and improving, and their skills are improving. And at the end of the 2 years, they might do much better than what on a certain unit test. So give them always that reassurance that it's a learning process rather than just a done deal for every single topic. For the internal assessment, definitely create a lab program that makes sense, that relates to the syllabus, that relates to the topic, and that actually incorporates all the required skills for the IA. I would really recommend that you use the IA criteria to assess lab work as training for the IA. And that does not mean that every lab report or every lab experiment they're doing requires a full write-up. You might just focus on, let's say, the analysis for one particular lab, or the evaluation for another lab, or nothing, really nothing as a write-up, just the skill, discussing it within class with the students, what have we learned, how to do the calculation, etc. So you really vary how you want to approach it, but expose students throughout the 2 years to all these criteria, to how to actually address them, to achieve them. I would also strongly recommend that you model a full IA write-up with the student. Create with them a design experiment and go through the steps of how to write a focused research question. And maybe that work, once you finish it together with them, will be their exemplar or their template for writing the real IA that they're going to get engaged in. I think that I've learned that this is really the most valuable experience for the students. They tend to go into their IA feeling much more confident and stronger in terms of the skills that they actually can use. Finally, how do we actually document all of this? What do we need to report to the IB? What do we need to keep? I would recommend you keep copies of everything. You never know. You never know what can happen and that you need evidence for something and whatever. Keep copies of everything you do with the students, their formative and their summative assessments. I think it would be just wise to keep them there. Definitely assess students formatively and summatively throughout the two-year program. Always keeping in mind it's a learning curve, it's a learning process, it's a learning journey that students will become better the more they get into all those assessments and practices and experiences. Keep progress of the student record of the student progress. Engage students in reflecting on their progress. Why is it that they're doing not so well or doing very well? What skills help them really develop? What skills do they need still to develop? And when you see that there are some weaknesses they highlight, or they're lost a bit, or they want to advise, meet with the students, discuss their actually weaknesses or their plans of improvement, and encourage them in a certain direction. Tell them what they need to focus on. It's okay, they need guidance. These students are learning and growing, and so your advice throughout the process, your encouragement, your support will really be crucial for their success. And it's really important, and I would recommend that you really get engaged in trying to moderate sometimes some experiments, definitely the IA. It really supports you in the process that, yes, when I'm discussing it with a colleague, I know what I'm doing. We agree on the grade. Maybe I'll be convinced otherwise. Maybe I'm going to be getting confirmations of my evaluation. And anyway, it's a requirement for the IB to internally moderate IAs if you are more than one teacher teaching the subject. What will you need to do at the end of the 2 years? Normally for the exam, nothing. The exams are administered by the school, by the IB coordinator, by whatever system that the IB agrees to with the school to follow. So you really have just to practice with the students, train them, review with them at the end of the 2 years. But in terms of the IA, normally what we do is that we predict grades for the students in terms of the chemistry course in general, but also the IA criteria grades need to be put into a system that the IB coordinator will train you to use. And so the system will generate a sample for the IAs. And normally there are 5 students for a certain number of students, or more than 5 students. Depending on the number of students, you will have a certain number of samples, that a sample of so many students that you need to send to the IE, so to the IB. So what you have is that after the system creates that sample for you, you have to upload the IA criteria, specific ones, the person engagement, exploration, etc. And you need to also upload the work with some notes from you to justify the particular grade that you've associated to the criteria for that particular student. So normally, again, it's a sample that is being sent after the system generates it. But in these couple of years, we've had all our students sent, or all the work of all our students sent to the IB. They regraded all the work. And that was due to the fact that some schools had exams, some schools did not have exams due to the COVID. And so they wanted to make sure that all the grades, all the IAs of the students were actually scored and moderated, and that the grades were reliable in that sense, because of course official grades were based only on IAs. So again, this year all IAs will have to be sent. So what you will need to do is input all the grades of all the students in the system. Definitely authenticity will be a huge issue. You will have to sign for the authenticity of the students. So please be careful that you know that you can testify for that. And basically examiners go through the IAs, and then they really, based on how they evaluate the work, they want to support the teachers as much as possible, but sometimes really it's impossible. It's really hard sometimes. And so you could be moderated up or down, normally down, but sometimes up. And please don't take it personally. I mean, they just want to achieve consistency throughout the whole word. And so normally take it as, okay, that's a great opportunity for me to learn and become better and see what the feedback is. Where was I moderated down? And learn and become better for later. And that's how we grow, that's how we develop, and that's how we learn, honestly, to become better graders, better assessors, better teachers for our students. And this really brings us to the end of our session. Thank you very much, really, for attending. I'm not going to keep whoever does not want to stay, but I'm really happy to stay for whoever has questions. Thank you very much for attending, but I think Sarah will take it from here as well. Sarah, do you want to end this with, or should I just...
Yes, for sure. Let's take some questions before we try to end the session. Right. So if you have any questions, you can share them in the chat box. We had a couple of questions a little bit back when we were talking about the internal assessment. So there was one question regarding the ethical and environmental concerns, how to address ethical and environmental concerns.
Okay, very good. And that is, again, something that students become better at doing while you do some practical work in the lab. So, or when you model an IA with them. So normally what they have to do is really research. I advise students, we're using HCl, go research it. Research the risk assessments related to HCl or to NaOH or to any other chemical we're using. And normally in their little research, they will tell them, okay, be careful about this, be careful about that. Well, if you cannot dispose of it in the sink, you need to dispose of it in a certain particular way. They really get it from just doing some research. And again, I advise students that once they do it once for some chemicals, they then can reuse the information for other labs. So normally they would do some risk assessment research related to the chemicals they're using, and they will come up with some suggestions of how to actually be safe and be ethical and be environmentally sound, really have good practices in terms of that.
All right. Okay. Another question was with regards to errors. If there are no such errors, how do we address that in the internal assessment? I'm assuming.
Well, it's impossible not to have errors. And again, it's impossible not to associate methodologies with errors. There's always room for error in every experiment. This is really more science than actually even IB. So students have to look into, and you know, it's not about having so many errors. It's about really discussing important aspects related to the methodology they followed. Maybe they have not collected enough trials, maybe not enough data points, maybe anyway, the uncertainty of the devices in itself is an error. Increasing number of tries is always an improvement. there's always something that they can discuss, always, always, always. And sometimes they can do some little research on the method they followed, and they might find that there are other better ways to do it, and they might suggest this in the evaluation that they actually write.
All right. And then the last question here is, how do we go about writing the bibliography? What's the process that you advise to use?
Okay. Normally, it's not really that they have to have addressed these resources throughout the report, but normally any resource they've used, whether for the research, the background research, or for the experiment itself, maybe they have followed a methodology from someone, or when they want to compare their study to other studies, they have to reference the work. And so normally they would list the works by alphabetical order. There is no specific format, so MLA, APA, no, there's no specific format as long as students are consistent with the way they actually format it, that it has to be clear. It's not just a link from the website. They really have to actually have the name of the resource, the authors, and they must have used it throughout the report, basically. Yeah. So there's no also quantity, limited quantity or required quantities. It's really what is useful to the students normally.
All right. Okay. All right. I guess that's it with regards to questions. Thank you, Ms. Dania, once again for this wonderful session today.
What pleasure.
I'm sure everyone who joined in is taking away very useful insights. We would also like to invite our attendees to attend Group 4 panel today at 11:30 a.m. GMT to learn more about supporting students with Group 4 projects. You can register through the IBDP Thinkathon website, or you can use the Zoom link in the chat box to join the session. Please pop the survey to give feedback towards the end. If you're interested in knowing more about how you can use Toddle at your school, we're doing a quick walkthrough to show you what Toddle has to offer DP schools today at 10:45 GMT. Do drop into that session using the link in the chat. Thank you so much for being part of the 3,000 educators who attended Toddle's first ever IBDP Thinkathon. All videos will be available on our website. We can't wait to share what we have planned for the DP, and we would also love for you to partner with us to create our platform. Please use the link in the chat to sign up. Thank you so much and have a wonderful day.
Thank you, everyone.